Hi, hello friends. Welcome to T Academy. Let's continue the GATE previous year solutions from the 2018 to 2022. In this video, we will discuss the previous GATE questions from the topic of network transients, and a few questions are from the magnetic coupled circuits as well as two-port networks here. We'll start the question here. That question is from the transients, and this question is asked in the previous year GATE 2020 question paper here. A resistor and a capacitor are connected in series to a 10 volts DC supply through a switch. The switch is closed at t is equal to 0 and the capacitor voltage is found to cross 0 volts at t is equal to 0.4 tau, where tau is a circuit time constant. The absolute value of percentage change required in the initial capacitor voltage if the zero crossing has to be happen at 0.2 tau is. So we know that there is a capacitor and resistor circuit here, and it is connected to 10 volts DC supply here. So resistor and capacitor is there, which is connected to 10 volts supply here, and resistor and capacitor. So generally what the capacitor will do is capacitor is going to be charged. Okay, so when the capacitor is going to be charged, its voltage initially 0, it's going to be raised like this. Now in the given question they said that the reference line here, it is somewhere, this is a reference line. So reference line at this is t is equal to 0.4 tau. So this is a question here given. At this particular point the voltage is crossing some point here. The voltage is crossing some point, the 0 point here, 0 volts, okay, at t is equal to 0.2. Now the given question is at what voltage, the same at what voltage it will cross 0.2 tau at t is equal to 0.2 tau here. That means in initial case it is a crossing at 0.4 tau. Now what are the changes that should be made so that it cross should 0.2 tau here? So earlier it is 0.4 tau, now we have to make it as a 0.2 tau. And what is the voltage that we need to change here? That is a given question here. If you understand the question, then answer will be easier for you, right? Now first of all what we'll do is we'll find the voltage across what is the point V naught here, okay, and after that we'll find the voltage at this particular point, say V naught dash, second case at 0.2, okay, this will be at 0.2 tau, and V naught will be what, 0.4 tau we'll calculate, and we'll find the difference percentage here. That's it. So that is the concept of this question here. Now here in the given question, so assuming that a resistance value is here, capacitance value is here, and 10 volt supply we are applying, and initial voltage across the capacitor is 0, okay. So capacitor voltage is found crossover at t equals 0.4 tau. So when the capacitor voltage is crossing at, for example here, 0.4 tau, okay, so it's crossing 0 volts means before this one is, it's a negative value. So before that instant, that is 0.3 tau, it is a negative value. So this is assumption you have to make here, okay. Now here we use the formula here, standard formula. What is the formula here? Vc of t is equal to V of infinity plus V of 0 plus minus V of infinity into e power minus t by tau. So this is the formula, standard formula you have to remember here. Okay, so by applying this formula we'll solve the answer here. Assuming that the voltage across Vc of t is 0, which is equal to V of infinity, okay, we know that infinity means V of infinity is nothing but when the capacitor is in steady state condition. When the capacitor is at steady state condition, it acts as a open source or open circuit. When the open circuit is there, entire 10 volts will appear across the capacitor voltage. So Vc of infinity is nothing but 100 volts, 10 volts here, 10 volts here. So this will become what, 10 volts, and Vc of 0 plus minus Vc of infinity. Now Vc of 0 plus means it is assumed as a negative value. The reason why I explained here, minus V naught, minus V of infinity means minus 10, and e power minus t by tau. So t is equal to 0.4 tau and t by tau is equal to 0.4 here. So I already substitute value here. Then by using the calculator you can solve the equation, and you found the value it as 4.918 volts. So V naught value, initial value, it is 4.918 value. Now next case is at what changes that we made to make the voltage 0 at 0.2 2 tau here. Now Vc of t should be made 0 here. Okay, V of infinity will remain same plus V of 0 plus minus V of into e power minus t by tau. So 10 plus here, assuming that voltage will be negative, so minus V naught dash minus 10 e power minus t by tau values, no, in case is 0.2. Substituting that, you will get the value of 2.214 volts here. So these two are there. Okay, now percentage change in voltage, how much changes we should make? So V naught minus V naught dash divided by V naught. So by substituting that value here, you will get the answer as 54.99 or approximately 55% you have to change here. So I hope you got the answer here. That means if you are changing the voltage with the 55% of the initial voltage, then we can reduce the instant where the voltage is going to be 0. Okay, so that's the answer. Next we'll discuss a question here. Now here. Okay. Next question. Okay. In the circuit, the switch S is in the closed position for a very long time. Okay. So switch is in which state? Closed position for a very long time. That means the steady state has occurred. If the switch is in open now, that means we are going to open the switch at t is equal to 0. Then IL of t in amperes we need to calculate here. Okay, simple question here. So same formula that we applied previously, the same formula we are going to use now. Okay. Now before the switch is closed position here, where long time means it is short circuited like this. Now which is short circuited means inductor also acts as a short circuit. When the inductor acts as a short circuit, what about the current here? So let us assume IL of 0 minus is equal to IL of 0 plus, which is equal to what here? That here we have plus minus 10 volts, and is a short circuited means directly we can apply KVL in this loop here. Okay, KVL loop, but it's a short circuited means, so we have to use the loop in this direction here like this. Okay, short circuited means this, and this will not affect our voltage drop here. So voltage drop across this circuit is 0 here, so 0 volts here. So minus 10 plus, so 0 volts plus I into 1 is equal to 0. So similarly IL of 0 minus same is equal to IL of 0 plus is equal to what? 0 plus is equal to what? 10 amperes here. So that is the what I have written here. So IL of 10 minus 10 amperes here. Now at t is equal to 0, what is happening? The switch, we are making the switch opened here. When the switch is opened and at steady state condition, inductor acts as a short circuit here. So that is what I have taken here. Okay. So now at t is equal to 0, the switch is in open condition and the current will be IL of 0 minus is equal to I of 0 plus is equal to 10 amperes. But at t is equal to greater than 0, when the circuit has attained steady state, then inductor acts as what? Short circuit. Capacitor will act as a open circuit. So somehow capacitor is not there in the circuit. Inductor is going to act as a short circuit here. So I have redrawn the circuit here like this. The switch is opened here and 10 volt source is there, 4 ohm resistor is there, 30 volt supply is there, and 1 ohm is there. Inductor acts as a short circuit here. Now I of infinity means steady state condition. Applying the KVL inside the loop here. So KVL inside the loop, minus plus or minus means minus 10 here plus 4 into I plus here minus 30 plus I into 1. So I will be here written as I of infinity. You can consider here 0. By solving this, you will get the current as I of infinity as 8 amperes here. Okay. Now here to find the R equivalent. Why? Because in the substitute equation we need to find the e power minus t by tau like that. So tau value we need to calculate. So tau is nothing but L by R or R into C. Okay, L equivalent by R equivalent, R equal to C equivalent. So either you can consider. So the given question asked about the inductance and resistor circuit. So tau will become as L by R. For that one, to find the R equivalent value, we will make the source zero technique, which I already discussed in the previous network theorems questions. So we'll make a short circuit here, and the switch is always open condition at t is equal to greater than 0, and 4 ohm resistor is there, and here the voltage source, again I am making a short circuit here. Okay, and resistor is there. So from this side where the inductor is there, from this side we are looking for the R equivalent value. R equivalent value means 1 ohm resistor is there, which is series with the 4 ohm resistor like this. So entire resistance will be about 5 ohms here. Now tau is equal to L equivalent by R equivalent, that is nothing but 0.5 value divided by 5. So where is 0.5? So already they given in the problem here, that is okay, that is 0.5 they given in the problem. So the value we have same taken here and is equal to 0.1 seconds. Now this is a formula here. IL of t is equal to I of infinity plus IL of 0 plus minus I of infinity e power minus t by tau. So I of infinity, 8 amperes. IL of 0 plus means 10 minus 8 into e power minus t by tau. So once you got this equation, if you are simplifying, you will get the answer as 8 plus 2 into 10 power minus t. So 8 plus 2 into 10 power minus t. So will be the answer here for this question. Okay. So similarly, we'll move to the next question. Right. Okay, fine here. Now, the question here it is, in the circuit shown below, the switch S is closed at t is equal to 0. So, the switch is closed at t is equal to 0 means at t is equal to 0 minus the switch is in open state condition. That point you have to understand. So, t equals 0 minus the switch is in open circuited condition. The magnitude of the steady state voltage in volts across the 6 ohm resistor is. So, the magnitude of the steady state, understand here steady state voltage here. Okay. Now see here, you have to understand the concept here. T equals 0 minus current. Is any current flow here? Is any current flow? No. Why? Because source is not supplying current. Initial voltage across the capacitor is Vc of 0 minus is 0. Okay. So no voltage source is there. Because of no voltage source, there will be no current here. Okay. No current means no voltage drop. So there is nothing to discuss about. T is equal to 0 minus case here. At t is equal to 0 plus, we have to consider here. At t is equal to 0 plus, what is going to happen? Okay, so t equal to 0 plus at steady state condition. Steady state condition, we know that we discussed that inductor act as a short circuit, capacitor act as a open circuit. Now, during the steady state condition, let us assume that the switch is closed here. This is closed, and this will act as a what? Open circuit. So when there is a open circuit, no current will flow. There will be no voltage drop here. So no voltage drop means we can neglect this entire calculations for voltage drop calculations here. Okay, so that's what we have done here. Okay, so here I considered it as a open circuit here. Now I have taken the same network, minus plus 10 volts and 2 ohm resistor is there, and a parallel combination of these three will be 6 into 3 by 6 plus 3, 18 by 9 here. It is nothing but 2 ohms. So here equivalent will be 2. Now current what is there? So we need to find the current. So I is equal to entire voltage divided by total resistance is 4, is nothing but 2.5 amperes. That's what I have written here. Okay. Now, so either you can use a voltage division rule or current division rule. You can simplify this network. Once you found the total current here, you can apply the current division rule here. So I6 will be what? Okay, total current. So total current 2.5 into opposite resistance divided by total resistance here. So simplify this one, it's going to be 2.5 by 3. Now we want voltage drop. V is nothing but I into R. So 2.5 divided by 3 into 6 volts is going to be 5 volts here. So for this network, the answer will be, here it is, 5 volts here. Okay, so we'll move to the next question here. Yes, this question is from the 2-port networks. Okay, the 2-port networks, and this is a GATE 2019 question here in the 2-port networks topic. In the 2-port network shown, H11 parameters, when the H11 is V1 by I1, when V2 is 0, that means there is a short circuited in ohms. So we want to find the value of H12 here. So the same network they are given here. So here what is there is a current source is in parallel with a resistor, can be represented as a voltage source in series with a resistor here. So we are converting this entire network by using the formula of V is equal to I into R. So I can convert this dependent current source into voltage source multiplying with 1 ohm resistor here. So this will become what? The current source is going to become a voltage source here. So that's what I have written directly here. There is a voltage source in series with the resistance of 1 ohm here, and the entire network is there. Okay. Now we will apply the voltage analysis here. So we'll apply the analysis here, that is nodal analysis VA. Okay, so VA minus V1 divided by 1 plus VA by 1 plus VA, and here's a minus sign, plus sign here. So VA plus 2I1 divided by 1 is equal to 0. We know that V1 is 1 volts, and by substituting here we will get the one equation here. Okay, so from that equation we can find the value of I1 as 1 minus 3 VA by 2 here. So one equation here. Now by applying the KVL in the first loop here, so assuming the KVL in this loop, I1 value equal to 1 minus this is 1 minus VA by 2, VA by 1 here, so VA by 1 ohm here. Okay, let me correct here. Okay, VA by 1. So from this we will get the value of I1 value. Okay, so I1 or VA we can substitute here. So by using these two equations we can get the value of I1 as 2 amperes. Okay, as you can see here, I1 is going to be 2 amperes here. Now H11 is nothing but V1 by I1. We know the V1 value as 1, and what about the I1 value is 2. So it's nothing but 0.5 units are ohms here. So answer will be 0.5 ohms here. And we'll move to the next question here. The input impedance Z in of S for the network shown here. So we need to find the value of the input impedance here. So input impedance can be found with the help of V1 by I1 here. So here we have a magnetically coupled circuits here. So here you have a dot convention. Current entering at the dotted terminal of one coil will produce a EMF positive on the other coil. Current leaving at the dotted terminal of one coil will produce opposite polarity. That means a negative here, negative and positive polarity on the other coil here. So this is a concept you know from the dot convention. So from the dot convention we have written this diagram here. So V1 I1 is a 4 ohm resistor, and here we have 6S and S into I2 with a minus polarity, and here we have S into I1, and here we have dot polarity, I2 will be there here. Okay, so simply applying the KVL in this loop here, in the loop 1. So loop 1 means here we are going to apply. So minus V1 plus 4 into I1 plus 6S I1. Okay, so minus S into I2 equal to 0. And similarly we will apply the loop analysis in this loop also. I2 will be, so minus S into I1 plus 4 into S plus 5 ohms is equal to 0. So we have applied this, and when we are going to substitute these two equations, we will find the answer Zn value as 23S square plus 46S plus 20 divided by 4S plus 5. So answer here it is B is the answer here. Okay, sorry, it's not 23, B is the answer, right? Okay, B is the answer for this question here. And we'll move to the similar kind of question that is asked in the same paper here. An air core radio frequency transformer has shown in the primary winding and secondary winding the mutual inductance M between the windings of the transformer is. Okay, so here we calculate the M value. Okay, so voltage source is given here, but there is not mentioned about the voltage magnitude. 100 kilohertz is given. Okay, and here we have winding, primary winding, secondary winding, and there is a 22 ohm resistor is given, so which will having a peak to peak magnitude of 5 volts here. Okay, so here the current is flowing here. Okay, there is nothing about to discuss about the inductance value. There is no inductance value also given. Okay, there is no voltage value given. Okay, so only thing we know is the current value. So current value 5 volts, there is a peak to peak value which is equal to 22 ohms into, assuming that the current flowing here it is I1. So I1 here. So I1 is equal to what? 5 volts peak to peak divided by 22 amps is the current flowing here. Now here output voltage, there is a V0. So V0, there is a formula is there. So V0 is equal to J omega I1. Okay, so this is an important formula. Now J value we know. Okay, J 2 into omega means 2 pi f. Omega is nothing but 2 pi f value. So 2 pi f value is given as a 1 kilohertz here in the given question. 100 kilohertz, sorry, 100 kilohertz. So 100 kilohertz we have taken here into m into I1 value is 5 divided by 22. So substituting this value, you will get the answer as a 51.10 micro henry here. Okay, so let me correct here, the frequency is 100 kilohertz. So here I have mistaken, here 100 here. Okay, substitute the value, you will get the answer as this 51.01 microhenry year. Okay, so that's it for this session, friends. We'll continue in the upcoming videos. Thank you. Have a nice day.